Okay, so this is transport's homework number 4, and what we're given is we're given this system in which we have a holding tank and we have water that flows down a pipe into a jacuzzi, and this jacuzzi is kept at a constant height of 1 meter by pumping water from the jacuzzi back into the holding tank. So basically what we want to figure out is how much power is needed for this pump in order to pump the water back into the holding tank. We're also assuming that this system, all of the water that's going in is equal to the water coming out. So because we're assuming this, we're going to be using Bernoulli's energy balance equation, which is the change in pressure over rho plus gravity, change in Z plus VB squared minus VA squared all over 2, and this is equal to the work over M plus this F. And then so basically what we want to do is we want to simplify this equation according to our system. So the first part that we're going to look at is we're going to break this into 2 sections. So we're going to look at the water that's going in. So we're going to take this basically from this point until this point. So this is going to be P1, this is going to be P2. And we're also assuming that this is our starting point, so I have this at 0, and this is our ending point, so I have this at -10 according to the measurements that we were given. So simplifying this equation down according to what we have is we're left with P2 over rho plus gravity -10 plus V2 over 2, and this is all going to be equal to 0. And so we know that pressure is equal to rho times GH, and we know that this height is always kept at 1 meter, so we can have this equal to 1 meter, and when we do that algebra, that just turns into 1G. So we can go ahead and plug this back into this, and then when we do that, we get 1G minus 10G plus V2 over 2 equals 0. And then so now what we want to do is we want to solve for V2. So when we do that algebra, we get V2 is equal to the square root of G. And then we need to figure out basically what our flow rate is. So we're going to have QZ, and we know that this is our times area. And then we want to solve for V2 because that's what we have here. So when we do that algebra, we get V2 times, this is our area, which is here, squared. And then so what we're given is we're given that the diameter of this pipe is 10 inches, and we need the radius, so we know that the radius is equal to 5 inches, but we need to convert this to meters, and when you convert it to meters, this turns into 0.127 meters. So when we plug that back in, basically we have 18G pi 0.127 squared. And then we're going to remember that, so we'll just start that. So now we're going to go to the second part. The second part was we're going to try to find out the water that's leaving the jacuzzi. So we're going to use Bernoulli's equation for this again, but this time we're going to simplify the Bernoulli's equation according to this point within the jacuzzi to this point. So we're going to refer to that as P2 and P4. So when we simplify this equation according to these 2 points, we're left with G times Z4 minus Z3 is equal to the work, because there is going to be work, And then, so from this, we want to solve for the work. And when we solve for work, we get, oh, I forgot these. Okay. Times gravity times Z4 minus Z3. And we know from what the measurements that we were given that this is going to be equal to 9 meters. And we'll just, I don't know if you can see that. There we go. Okay. And so we have this. This is our volumetric flow rate. And what we have to do is we have to change this into a mass flow rate. And since we're dealing with water as our liquid, we're going to multiply this by the density of water. And then so when we do that, we're just going to have our 18g times pi of 0.127 squared times the density of water. Okay. And then, so when we want to determine our power, we know that power is equal to our pressure times our 18g times pi times 0.127 squared times 9.81 times 9 meters. This is the density I should have put. There we go. Okay. And then when we do the math for that, we get power is equal to, this is 1,000 kilograms per meters cubed. We're going to use 9.81 for gravity. Extend that. This is our pi again, 0.127. So be in meters cubed. Or squared, and times our 9 meters. And when you do all of this and our calculation and you get that units converted, we get that our power is equal to 60 kilowatts. About 60 kilowatts. And then so since we know that there is power that's needed to be put into the pump, this power is going to create heat. Therefore, we're going to need a chiller in order to keep the temperature at a constant rate to combat this heat that's being produced.